Hello, this is Bill again, and welcome to Designing Pylons, Module 8. And before we get there, we'll just recap what we did with Module 7. We talked about the sheet metal to aluminum transition and storefront material alternatives. So let's go on with the pylons. Pylons have and always have been the integral part of any sign designer's job list. And learning the basics of sign design changed over the years from a free-form, free-for-all type of sign shapes that sheet metal allow you to do, to the more restrictive area of aluminum and the architectural prerequisites of sign shape and sign retention systems and graphics and how to incorporate it into these substrates. So it's changed. But the basic rule of thumb, again, and a rule of thumb based on sound engineering principles that was used by designers as a guide. If for any reason there was any doubt or there was a requirement from any municipality that this had to be validated, then of course it was given to an engineer. But most sign shops avoided going to an engineer. It was like going to the dentist for most people. So we worked with established principles of sign design, and it was based on surface area, center of gravity, and the transition of that force, that load onto the base plate. The base plate took the brunt of it, and of course the cement base. The cement bases had to be below the frost line, which in Canada can go from anywhere from 4 feet 6 inches, and most sign shops would go that extra 6 to make it 5. Anywhere up to some areas like Seven Islands in the northern Quebec that would go to 7 to 8 feet, and so on. It varied on the climate, the area of the country, and wind loads. Most of the wind loads were based in Canada were at 30 pounds per square foot. In the US, and when you're shipping signs to you, it could vary anywhere between 35 pounds per square foot to 50, 52, and 75. I have seen Gulf signs that were formulated. As I said, most of the signs came pre-analyzed by engineers, and they would have these this analysis and soil conditions established beforehand, and all they would do was just check the list off. But this is the basics. And once you determined the what you required, you would usually get a section modulus, or the weight. The section modulus would define what type of a pole you would need. So what we would look at is the section modulus required by the formula came up to, let's say, 6.4. That would mean it's a 4-inch pipe, and we would incorporate the 4-inch pipe. It's as simple as that. And the rest would be done by the permits people and so on. And the weight of the steel plates, we had that too pre-established. Everything was set for us. So the designer really didn't have to do any engineering and any thinking. It was relatively easy. These are some of the charts that were used. Not everybody used the same formula, but they were close and they resembled one another. The place that I worked with back in 66, 67, this is the chart that they adopted and they used for just about everything. And it gave us a broad range of heights and sizes that we can cover. And again, we could use twin posts, we could maximize the poles, we could put multiple fascias, and we had the formulas. We followed those formulas, and it was checked by the estimator to make sure that the designer didn't get crazy and wanted a floating sign. So we had a chart for circular footings and rectangular footings. Now, one important distinction at that time, and that was the tendency in the US for direct sink. They would sink the pole directly into a concrete footing and concrete base. And in Canada, while there was a good mix in the early 50s to do that, increasingly municipalities insisted on anchor bolts. That reason for it is because of the frost and the thaw would cause, in some instances where the base wasn't properly, or the soil wasn't properly compacted around the base, it would shift. So we'd have a lot of leaning tower of Pisas. And that was that's something that we quickly, the industry in itself, even though it wasn't organized as it is today, quickly learned that it was better to spend a little extra on the cement and to put in an anchor bolts with grout and shim them and allow for a proper and a straight pylon sign. But these are charts that I recouped from the morgue here at the Patterson. Nobody knew they existed. I found them and I used them to show you, to demonstrate how easy it was for the designer to follow. That was both even before the distinction was made between the creative people and the engineering people. Everybody used this as a chart to get an idea of what size pole to use for a particular sign. Anything beyond that would, of course, necessitate an engineer. If you got a little fancy and you got a little creative with your pylons design and pylon shape, that's what you did. This is what I called a bidding war pylon design. In the early 70s, just about every oil company in Canada at that time there was BP, Texaco, Esso, there was Champlain and Sunoco, a wide variety of, they've all since merged and disappeared. Petrofina became Petro-Canada and so on. But they all sort of hung out in areas where they didn't have the major, their primary or corporate look. These were secondary signs. They used this particular design that was so easy to construct. Just it drove sign companies crazy because it allowed for inferior sign shops that didn't have that much of an overhead to come up with some ridiculous pricing. And it was very simple. Used a hollow section. You welded a flat bar on the inside. That automatically became your casing. Your sign pole and these flat bars made it a sign casing. You had a horizontal bar in the middle. And then you put an EX or any extruded section to support a flat face, and you were in business. In the interior was with angle iron, was the perimeter. At the bottom, you had to fold over some aluminum, and you automatically had a raceway. The sides were used to pin right up against it. This was so easy to make, you could knock this thing out in a day. In a day, you had the whole sign completed. That's how fast it was. And that's why I call it the bidding war pylons, because when you had to bid against this, boy, you had to sharpen your pencils, and you had to make sure that you had a tremendous deal from your steel supplier. I was always bored with the idea that if I had to make any shape sign, I always had to use a steel post, and then I had to clad it. I had to build something around it. And it occurred to me that when I looked at a hollow section steel, and at that time we used a lot of 6x10s and 8x8s and 10x10s, and I looked at it and I saw that in most cases the section modulus described them as having 1/4 inch walls. Then I went a little further, and this was around the time I haven't been able to find a picture of the pylon that we designed for the Olympics. One of the Olympic sites. It was a 45-foot pylon, triangular in cross section, and it occurred to us 45 feet. We would have to have some steel posts. We would have to use cladding. We have to wrap it up, and the architect in question wanted some aggregate on it. And we stood around and says, how can we get this to be easy and efficient? And we decided we're going to call on some steel fabricators to make us a triangular hollow section. That sign is still standing today. If anybody's interested, I could send you to the Claude Robillard Center in East End, Montreal, where there's a giant arena, and there's a 45-foot pylon made in one single form of welded steel plate, 3/16, properly primed with epoxy primer and finished with a sort of a stucco finish on the inside and spray painted. It's still there. So when this particular project came along in around 1998, it's about 20 years ago, roughly 20 years ago, there was one major site for the Bombardier main plant in the Ville Saint-Laurent, and 6 other sites clustered around the airport that would describe the various divisions. And the idea was, of course, that we're going to make it an aluminum cladding. We're going to have a center pole moused. We're going to have cladding out of aluminum. We're going to form and we're going to weld and put together. And the designer in question challenged us. Is it possible for you folks to build something without that welding, those seams, because they show up? And at first we would say, well, no, we weld very well. We're defending our welding system. No, it doesn't work that way. He was too wise for that because he's seen a lot of these welded aluminum fascias and pylon signs with curved faces. And he noticed with metal fatigue, and yes, signs do suffer from metal fatigue, just like old airplanes that you see with oil canning sides. It's because they've been flying for thousands of hours and the wind has ultimately distorted the metal. Well, the same thing happens to aluminum signs, to the point where no matter how well you've welded the sign over a period of time, it's going to witness that weld. He didn't want that. So he says, well, why don't we try and do the same thing? We went back to our trusty old steel fabricator that could do refinery tanks and so on, and says, do you think you could produce this for us out of 3/16 steel? And we're going to anchor it, make it all in one piece. And this is what we propose. This is from memory again. I sketched this out to show you the basic principle of it. The graphics did not have to be illuminated. They were going to be externally illuminated, and that was the saving grace, because we were hard pressed at thinking of using perforated steel, routed steel, and push-through graphics and the issues of servicing. So, given that it was going to be a pure monolith with applied graphics, this was the solution. To this day, it's still out there. No rust marks, and if you go, we'll go back and I'll show you the previous. The one on the left measures 8 feet by 24 feet in height, and that is in the secondary pictures. All the others are 6 by 20, and we had to add these address modules up against it. The graphics on it are pigmented black acrylic cemented to that epoxy finish. Actually, it's called a Durée 500. It is a paint that we borrowed from the Shell program that was guaranteed for 25 years. Well, the signs have been up now since 1998, almost 20 years, and they're still impeccable. They're still on site, and it's a little bit of a masterpiece. Again, let's review what we've done. We took 3/16 steel. From memory, I'm pretty sure it was 3/16. Could have been a quarter, but because the reason I think it's 3/16, he was very fussy. He wanted very sharp corners, and we could only get so much out of a quarter, so we used 3/16, and it was corroborated because we did have this validated by an engineer, and this entirely welded situation. Given that the anchor bolts were going to be hidden by crushed rock, we were able to integrate it. We covered them with creosote. Once they were installed, to make sure that they wouldn't rust. That sign is still out there, all these signs, and I'm rather proud of it. Then when we did that Olympic sign, we first used it on the Shell program, and I'll show you first how it was specified. When we did the Shell program, the columns had to conform to the shape, the fascia shape, the curved face of the center pole and flagpole signs. The monoliths at Shell were not allowed in certain areas called daylight corners. I'm sure most municipalities have them where they'll block the installation of any monolith as an obstruction to viewing traffic at any intersection. So these were called daylight models, both center pole and flagpole mounts. Now I have the flagpole mount. That's the post mounted, and there's the flagpole mount is on the right, extreme right-hand side. So again, it was specified as a hollow structural steel clad with ACM, and with the integrated, no visible fasteners, extruded sections, so that it would look as much as possible as a monolith. We went to Shell and we proposed the alternative. And that alternative, I'll show you in a second. There we go. Then we go again. And then there's another one. And here we go. The one in the middle, the one on the left is a center pole, and the one on the right is a flagpole. And it conforms to the face of the sign as it goes into the escutcheon, the lower portion of the double face section. Here again, the only concession we had to make to the realities of the electrical connection is we made the service access so that we could ratchet the anchor bolts with this opening. We calculated it that this would be more than enough, and it was. And this is what, wherever you see these signs are going to be closely, certainly they're going to disappear eventually because they're still in the process of rebranding the shell program. But these signs are still out there, and when you catch them, take a look at them. This is not ACM, and again, it's finished in Durée 500, a paint that was imposed on the fabricator to guarantee at least 25 years. It's a labor-saving solution, and it's available in many areas of North America. Extraordinary steel fabricators, they're all over. Steel is the most underused of substrates in the signs, and it shouldn't be, because if we could easily adapt this concept to many of the pylon designs that we see today. It's a labor-saving device, and it's aesthetically just as pleasing. The other and most notable advantage is there's less chance of witnessing of seams, of welded seams that had to be filled and puttied and all the rest of it. It avoids all of that because what you have is the basic steel support of your pylon sign. Here's another example. Again, here's the customer. He was a multi-tenant building, and he was concerned that he was not going to be seen. He had a main tenant, a video rental service. This is going back, of course, several years. No one rents these things anymore. But I've managed to save a picture showing before the actual building and pylon or double face sign was installed. But it gives you an idea. This is also not a clad post. This is the post itself. It is made out of 1/4 and 3/16-inch plate, again properly finished, with the attachments pre-made and all the necessary openings for the electrical. It is a seamless design made entirely out of steel. If you could imagine this made out of aluminum, then you would have to imagine the kind of structure that you would have to incorporate behind the aluminum cladding. This is clean, simple, and it's taking advantage of the virtues and the strength of steel. The steel can be done in many different shapes and sizes, including Corten. If you ever get to Chicago, and I don't have a picture of it, but the famous Picasso sculpture was made out of Corten steel. The GM program originally in 1969 incorporated in all their signs Corten steel. It's a steel that paints itself. As it oxidizes, it puts on a patina and saves it. So there's an option in making these structures that I just showed you for Bombardier and the others, and for Shell, to do them out of Corten steel. And then you would have a sign that never rusts. Freeform concrete was used extensively in the 50s and 60s to incorporate signs. Here's one of the better ones that I retrieved. This was done sometime in 1964-65. It's a classic. It's a beauty. It takes the sweep and the elegance of concrete when it's done right, and it integrates beautifully with the architecture. This is one that I designed in 1974. I remember making the scale model for it. I made it out of plywood. I engraved the graphics into it and covered it with stucco. I remember a little can of Rustico. And I put a little box on top of that pylon. I set it on top of my car and photographed it with the pylon, with the building then being built, Carrefour Laval Shopping Center. And with my color Polaroid, I went into the meeting with my model and the picture showing what it would possibly look like. And it was sold. I worked exclusively for Cadillac Fairview and the pylons and the architects to develop this concept. This is precast. This was a company that unfortunately went under after the Expo 67. They lasted a few years, but they're well known for making these marvelous precast sections, and they were also part of the team that built Habitat 67. If you ever see Moshe Safdie's architectural wonder apartment buildings on the waterfront of Montreal, this particular company, Prefac, participated in it. Anyway, we made these sections. There were 12 in total, 6 main and 6 exit signs that were a little shorter, and they were designed in prefabricated sections with integrated steel anchors, both bottom at the base and at the top. So all we had to do is have these things installed. Conduits are up, we sat them down, and it was a breeze. These signs lasted till about 5 years ago. So 1974 till about 5 years ago. We're looking at 40 years in the field. The plastic faces, incidentally, were made out of plexiglass 70, an impact modified that you could not paint and scratch on because it would shatter. So these are applied graphics on that particular plastic. And this I brought in because the pylon sign can take so many different. We have a classic that we see all over. It's become a generic. And the ones that Claude Neon here, the part of the Patterson group, produce a whole bevy of them, and with curved edges. It has it's a classic sign, it's a classic look. The one on the left I photographed in Paris in 1994, yes. These were, again, this shows stamped and prefabricated panels, the light box, and they had Ferranti-Packard electronic message centers. The support systems were all integrated. These are steel plates that were covered and clad with aluminum, anodized aluminum plates. They look so fully integrated and beautifully designed. It's one of the nicest signs, pylon signs, and most functional ones, considering that this is an electronic message center, but the flip type, Ferranti. This was, of course, 1994. And, well, that's it. And we finished this off sort of as a teaser of what we're going to be looking at with another sign program in the next module number 9. Thank you. Looking forward to module number 9.